Hey guys, so I just thought I'd quickly show you some work I did on a particular project in this last semester for database fundamentals over at George Mason University. The class was IT 214. In this case, the project was about an IT company that I had to create. In this one, I created a company where I had a division that can have multiple departments. One department can have multiple employees. Furthermore, I also said that an employee can be of one of three types of employee. There's a quality assurance type of employee. Another type would be the accountants for a division, essentially. In the end, they're working for a particular division. And the last other type for the project was a desktop support. Now, in this case, what I decided was I would have to do some kind of design structures and using something that might seem new to a lot of people, I think, and that's called algorithm designs. And that kind of goes, I think, in hand with data structures and how they are manipulatable, and how they can be made so they're flexible, depending upon the project or the problem you're trying to solve. In this case, the problem I was trying to solve was how to create a database that could manage X number of employees and still be scalable for the future. Now, in this case, I didn't have to worry too much about overhead because it's a small scale project only for a class at Mason. So here is some of the Python script I wrote. I have some comments describing the data, or the ideal data, if you will, and some other side notes along the way, like generated, foreign key references, the max amount, auto generators, and then preparation work, essentially. And this is how I designed, basically, my own algorithm. It was a flexible one that allowed me to do a little bit of prep work for it and then change maybe one parameter in my for loop, ideally, and then alter the if statement nested inside that for loop so I can effectively create and manipulate and format at the end my data. And my data was essentially randomized in here. And that's where part of the design structure is in place. This is where design structures can either capture data, ideally. A lot of the time that's the case, that you're capturing data from a website form where people fill out forms. Another example would be paper forms that you fill out at, say, maybe the doctor's office. In this case, it was actually generated and then captured and then formatted for the database. Now, the database, I used a particular software package called Valentina Studio. In another video, I'll put the link in the description below and put it maybe around here in the video, so you can also click and see what I did there. And it's not too big. Basically here, this is just one of many scripts I wrote. This is for the department specifically. So let's analyze the code a little bit right here. So at the top, I have a max number of 12, and I have some sample data to describe. And I noted that certain things have to be generated by hand. So the import random is going to help me generate Southeast Asia Northern Tier and the employee count of 12,850. Now, prep work for the algorithm to work with requires certain descriptors. In my case, the descriptors included things called regions and another thing called words. Now they're made into lists, so it's a little bit more self-explanatory, and the variable names are also made so that they're also self-explanatory. And these were just things I came up with in my head. They don't have any real significance here. And that's when it stops with the prep work and you start like plugging and chugging into the generator and using the algorithm to generate the output. So I have to make something that's an empty list to store the fully generated information. Now, after that, I have to go and say, okay, well, for debugging purposes, let's make sure I can see the output as it's being generated and then captured. So we go into the for loop, now the algorithm really, and I say, okay, from 0 up until the max, which is up here, 12. Hint, hint, this is actually a good programming practice to do, something I learned in another class. I say, okay, well, inside the algorithm, I need to make sure I have certain parameters like region, word, a name, and the list to add it to. So coming back, we're talking about the if statement inside the algorithm to verify if something's been duplicated already or not. And if it's not a duplicate, then it's unique, obviously. And we can go ahead and add it into the basically the data table, the would-be data table later on. Now, this is only part of the work that's necessary for this. And later on, as you might be able to tell by comments, I have output validation, generating the output that says, I've generated some data, I've captured the data now, and I have it stored into a variable with a list that holds the number of generated things on that. Now, going further into the details is full department employee counts, and then these are kind of like my header comments. Again, same format, same general approach. You know, prepare a array or a list really in Python that's empty, and we can store the unique numbers into. Now, sometimes it's not important they're unique each time. Here is an example. Random department employee count can be random, sure. The numbers can be very close as well, and that's obviously possible. And they're pseudo-random numbers. Now, if in the for loop here, the difference you might notice is I say the length of the department names list variable. Now, above it says empty here, but it's been populated every time I appended something into it, and it was obviously appended at the end of the array. Now from here, we need to specify the length of the department names list variable because of the simple fact if we have it set to the maximum records number 12, this could be off or simply different number than what we had from our previous run, right? So our previous generation produced, say, maybe 10 records instead of 12. So because there was a duplicate, it did not try to re-randomize another number for the region and the word parameters. In that case, if I were to say 0 to the max department records here, that could cause trouble because if I have 10 here and 12 here, there's two that aren't going to be linked to a department name, right? So that can be a really important difference. And in databases, if something is not linked, that's like saying there's a null value. And if I don't want null values, I need to make sure everything is unique or at least linked. The same approach, we verify, we append, otherwise we say it's already been listed, and then again we do the same thing. The last thing that I may not have mentioned before was that from these outputs, okay, on the basis that the code is error-free and bug-free, I can take this generated and captured data, right, and I can use either online resources or I can do whatever other tricks I feel like trying to do, formatted and all these things, so I can make the actual SQL code, and actually add it to my project context, my SQL server. That's not too important here. What matters more is showing you guys how the algorithms were implemented here. And it's fairly basic, actually. This would be considered a very small-scale algorithm. There's many more complex kinds out there. There's many different kinds, and they're only really limited to your A, imagination, and B, your skills and abilities really to abstract things and build upon abstractions and so on and so forth. And it can really say a lot when you design your own algorithms and your own data structures to create vast amounts of data and all these kinds of fun things to do. So anyways, going back to the bottom here is database work, as I said in the comment there. So I connect to the database project file, and then I have to do all this other work that's preparations to add into and create the tables. And that's literally right here. That's what I like about SQL and SQLite. It's very English-like language. Here, the data manipulation is saying drop the table if it exists, and create it again, obviously making a primary key, these other columns with these data types varchar, and int, something you'll notice is it says 255 as the highest number here. That's because in SQLite, and I think in SQL Server slash MySQL, when I was actually working on my server, maximum is 255. Turns out that's just a limit that you can't work around, unfortunately. You could probably work around it by making other tables that are duplicates and then making another successful output that you use to extend that other output. If that makes sense, I don't know. Comment if that doesn't make sense. So lastly is the evident, got to add it into the table, and you can kind of see what that output looks like in the very end, and save it so that everything is saved and that nothing's corrupted. And that marks the end of this little video on basically designing your own algorithms, and just a little bit, I think, on like your own data structures, kind of. Like, comment, subscribe if you want more updates on this stuff. If you like the programming stuff, I'll be glad to add more to it. Say you want some more. Also, I will be doing more videos soon on some anime stuff if you're interested in anime, or if you just want to take a break. I also have some Minecraft and Age of Empires videos you can enjoy too. So have a good one.